Hello, everyone, and welcome to a new episode of our podcast, Tea With Elsayed. Today, we have a very special guest. I was following him when I was a PhD student. I was following his work during his PhD and after he did his PhD. Our special guest today is Dr. Youngy Kim. Dr. Kim is a professor at Civil Engineering Department at McMaster University, and he was holding a Canada Research Chair Tier 2. Dr. Kim joined McMaster University 12 years ago and keep doing an excellent research work. And what is amazing about Dr. Kim's research is that he's jumping from one topic to another. And this is something was really curious for me to know why Dr. Kim is working with multiple disciplines and multiple research areas. This is what are we gonna know today. Dr. Kim has received many awards and achievements, notable by the early career researcher. How are you doing, Dr. Kim?
I'm good.
Thank you so much for accepting the invitation and being one of our guests for this podcast.
Yeah, my pleasure.
Did you get your step tea today or not yet?
Not yet.
Okay. So our team did a great job on making a new recipes for the tea.
Okay.
So I hope that you're gonna like it. So do you wanna try our own step tea?
Yeah, absolutely.
Okay. So I'm gonna serve you this amazing step tea.
Thank you very much.
I'm get addicted to it. Hope so. It's not gonna be the case for you. And if you don't like it, feel free to say I don't like it. So let's start with, who is Youngy Kim?
Yeah, there is quite difficult question to answer. I thought about kind of who I am, and then I realized it is somewhat philosophical question in some sense. So to describe myself, I think I'm a person with a lot of curiosities. So, and lucky enough to have tools and people around me to investigate about my curiosity. So I throw my questions, and then I work with my students and then to answer the questions. So I'm a person with a lot of curiosity, questions, and ability to answer questions.
Okay.
I think that is the best way to describe or define myself. Yeah.
I think this is a great description of a researcher.
Yeah.
Because a researcher, you always ask questions and looking for it.
Yeah.
So let me maybe take you back to 20, 30 years back.
Yeah.
When you were a child or your early ages.
You have to go more than 30.
No, let's say, okay, because I'm 30, so let's say we are in the same age period. So what motivates you to pursue that environmental? So did you think when you were a child, did you thought about it that, okay, I'm gonna be a professor or I'm gonna work with an environmental topics? When that moment came, or what motivates you for that?
I've never thought about being a professor and an environmental engineer as well. I think I wasn't really specific about what I want to do in the future when I was a child. But I think maybe the reason why I become an environmental engineer is because probably the bad environmental condition kind of when I was young. I still remember I went to high school. Then my school was on the other side of a river. So we are living on one side of the river, and my school is on the other side. So every day I have to walk to school. There is a bridge crossing the river. So going over the bridge. And during winter it is okay, but during summer I started smelling the rotten kind of bad things from the river, coming from the river. And then of course in the river there is no fish as well because it is contaminated, highly contaminated. And then sometimes when the wind is coming from river to the school, then we can even smell the river even in the classroom. I think that kind of motivated me to become more interested in environmental engineering and then environmental issues, things like that. So I think that is. I don't think that is the moment when I when I decided to become an environmental engineer. I think that kind of experience kind of made me more interested in environmental engineering.
So was it because of the bad smell or missing the fish? Did you fish when you were a child?
I fish. I did fish when I was little, but it is not in the river. It is in my mother's parents, my grandmother's grandparents' house, near my grandparents' house, in a rural area, but kind of in big city. I lived in a big city, Seoul, in Korea, so the river was not really clean at the time. Yeah.
Okay, so let's jump to the graduate studies that is really having a lot of memories and a lot of experience. And if you tell us a little bit about your graduate study, so where and what was the topics for your master and PhD work?
My master's degree was about it is what is the groundwater remediation. And then my PhD research was on electrodialysis for desalination of groundwater. And then it was not more on experiment, it was more on modeling. Oh. So at the time, during my PhD studies, I defined myself as a modeler rather than experimentalist, which is very different from very different from now. I did my PhD at the University of Texas at Austin.
Okay.
Very hot, very different from Canada. Kind of big temperature change.
Yes.
From then. Yeah. So yeah, it took 4.5 years to complete my PhD, and then I really enjoyed.
Okay.
I did my PhD work there with a lot of good people as well. Yeah.
Yeah. So during our graduate study, typically our relation with our supervisors play a crucial role on our career and our life. How was your relation with your supervisors during the master and PhD study?
Yeah, during my master, PhD, and postdoc, I have really great postdoc supervisor as well. So I had really 3 great teachers that I had. I feel very lucky to have them, especially at the right time. So my master's supervisor, his name is Youngy Kim. Same last name.
Same family.
Yeah. Not the same family. In Korea, the last name Kim is very popular.
It's common.
About 1/4 of the population, more than 1/4 of the population.
Oh, they are famous there.
Yeah, very famous. Yeah. Well, we are very famous. So his name is Youngy Kim, and then he, maybe at the time during my master's degree, I was kind of complaining that he wasn't really into in research. So he was more like educator rather than researcher. Okay. Now he's very active in research, but during the time when I was doing my master's degree, he didn't spend a lot of time on research, but he worked on teaching a lot, and also and then his teaching style is very, very unique. He's going deep and deep. So when he teaches something in engineering aspect, he tried to explain maybe engineering tool, engineering phenomenon, using all the basis of natural science. Okay. So for example, when we do mass balance, there's some differential terms, and then he doesn't simply use differential terms. He started from kind of selecting a control volume, and then he even go back to the definition of differentiation, like f prime x equals fx plus h minus fx divided by h, and then h goes to 0. That kind of concept. He even used that kind of concept. So which gave us a chance to think about fundamentals of engineering tools that we use. So he focuses on kind of educating fundamentals of engineering. So that I was really lucky to have very strong foundation of natural science in my engineering career. And then my PhD, my supervisor, his name is Dr. Des Lawler. And Dr. Lawler, focuses more on, maybe it is not his intention, but he focuses a lot on independence, research independence for me and my colleague, mainly because we are working on a project which is not really familiar, which is kind of beyond his kind of previous research expertise. So his original research expertise is particle removal in drinking water treatment. So like a coagulation, flocculation, sedimentation, things like that. But he kind of was funded in a project where we research electrodialysis. He has no idea what electrodialysis is. So every time we had a meeting, he always told me and my colleague at the time told us, okay, now you guys teach me kind of what electrodialysis is and how it works and what your research is. So because of this kind of, I had to develop a lot of independence in my research, and then he encouraged us really a lot. And then as a result, I became more independent on research. So that was my PhD studies, PhD supervisor, and then my postdoc supervisor, as you know, is Dr. Bruce Logan. Yeah. He's a really big guy in the field. And when I first came to his group, and then we had a group meeting, I was shocked that there were like 40 people.
It's a Bruce Redlands.
Yeah. So I was really shocked. And then as you know, he focuses more on research, and then kind of I learned from him about how to become productive in research.
Okay.
So I think I was really lucky to have the right person at the right time during my master's, working on fundamentals, PhD, kind of improving my research independence, and postdoc kind of improving
apply the research more.
Exactly.
Yeah.
So I feel very lucky to have kind of wonderful my supervisors.
I think, so as a graduate, since we are lucky when we have a great supervisor that is keep an impact on us. So if you pick one thing that is you kept from your supervisors and you are using it now as a because now you are a professor, you are supervising students. So what is the thing that you kept from your supervisors and you are applying to your graduate students now?
Yeah, for what I learned from my master's supervisor, I try to use as much as what I learned in undergrad and graduate education. So that is really unique to connecting engineering to natural science, fundamentals of natural science. I try to ask questions to students, kind of why and why. Try to explain using the language in natural sciences. And then that is the lesson, and then what I'm using in my teaching. For my PhD supervisor, as I mentioned, I try. Now I focus independence.
Yes.
Emphasizing independence to my students.
Yeah.
So kind of every time we start a new project, if I give a project to my son, I told my student, okay, this is your project, not my project. Okay. So you're responsible for it. So so that makes my student more independent. Kind of feel more independent on the research. So when I say, okay, when you write a paper, when you make a publication, and then when you get a final copy of the published paper, I want my student feel that, okay, it is his or her paper, not supervisor's paper. So that is what I emphasize for my PhD. And then also, kind of for my postdoc supervisors, the lessons from him, it is so obvious, kind of making publish, and then a lot of tips and skills in writing research articles, research papers. So I think I use a lot of what I learned.
Let's take your memory a little bit further. So when you graduated from the university and get your bachelor, how did you decide I'm going to go for a postgraduate study, a master degree researcher?
That's a Good question. But to be honest, I had no idea. Maybe it's a destiny. When I finished my undergrad, I've never thought about going into industry. I just wanted to give it a try to grasp it. Probably it is because I really liked the way of the teaching of my master's supervisor. I really liked it, and then I want to learn more about what he is emphasizing in the course in the courses that I learned. So. Yeah, I think at the time, I did not much thought, and then I'm just going to.
So maybe the instructors or the teacher during your undergrad study has some kind of inspired you to work on the research side. So aside from your master supervisor, are there any other professors or instructors that is really impacted?
That is a good question. Yeah, there is a professor. I really enjoyed soil mechanics during my undergrad. Even though I decided to come to environmental engineering. So I think I really enjoyed his teaching style and his material. And he has a sense of humor, which I don't have.
Yeah, that's important.
So I think he is one of my favorite professors.
Do you remember his name or her name?
His name is Inmo Lee.
So it's not Kim.
Not Kim. Yeah, he's not Kim. Yeah.
Okay.
Yeah.
Aside from the academic part in your life, there is any other person that is outside the academia or outside the education system that inspired you or has a positive impact in your career?
Yes, maybe it sounds weird, but I want to say meditation. I did meditation a long time ago, but I was not a regular meditator at the time. So, but I do know that it affected a lot on my career and my success in my career as well. And then about 1.5 years ago, I started meditation very regularly.
Oh, you started?
Yeah.
Okay.
So it's been 1.5 years. It has made me changed a lot in many ways. So make me more productive, more creative in research project, and more flexible as things, and then maintain positive attitude to my daily life and to my colleague, to my students. So
maybe we can arrange for a special podcast about meditation. No, I'm serious. Yeah, that's because this is really something we all needed after the pandemic.
I'm not at the level of teaching the technique to other people.
Okay.
But I can tell you where I learned the technique. So it is in Ontario. It is near Barrie. It is called Ontario Vipassana Meditation Center.
Okay.
And then they offer a 10-day course.
Okay.
So I attended one 10-day course like 1.5 years ago. It was really amazing. I mean, you are going to be disconnected from everything. So for 10 days, you go there, you surrender your cell phone.
Oh.
Yeah, it is complete disconnection from outside. And
wow.
Then you
no cell phone?
No cell phone, no connection to internet, no.
How can you
and then you get up 4:30 in the morning, meditate, and then until 9 p.m. It is 10 days. To be precise, 11 days and 12 nights. 12 days and 11 nights, and then after that, it was like wow. I was like wow. That made me so energetic afterwards. I mean, everyone suffered from the pandemic period, and then
yes,
I was one of them. And then after studying meditation, that made me so energetic and positive.
I will think about it, but the major challenge will be to find those 10 or 12 days
that is very difficult.
Yes, that is very difficult. Yeah. So When did you check your email after that meditation? Was it a big shock?
Surprisingly, not many. I was surprised that there are not many. Usually, we receive emails like
Yes.
100 emails every day. 100 maybe too much, but there's not much. Maybe it is because near the end of December. So
Okay. So this is something we can really think about it. But you mentioned that you enjoyed your graduate study, and it looks like when you are talking about it, it was a good time. So we always have those great moments during our graduate study, but also we have challenging moments. If you pick one or two challenging moments that you faced during your graduate study, and how did you deal with them? Let's start with the challenging moments.
challenging moment.
Or a
I
tough
think the
moment.
most toughest moment that I had during my grad studies is like final defense.
Okay.
Yeah, final defense itself, it was okay. To be honest, I enjoyed my whole research, the journey of my PhD studies. The final defense was itself, it was okay, but after finishing my final defense, I wanted to find a job. And then, that part was the hardest part, I think. Yeah, so
you were stressed before the defense. So what did you do to release that stress, or you just went with that?
I'm so stressed during
For preparing for your defense. So there is any hint to give to our graduate students that who are going for their defense to just relax them a little bit?
Okay, just believe that you will do well.
Okay.
Believe myself that I will do well, and then I think that is the only way to overcome the challenges during the grad studies. So I mean, I've been working. I worked hard over the past several years for my PhD. So I believe that I will do well. I will do well. I think that is my way to handle stress.
Yeah, if you are well prepared and rehearsal for your defense, and it's gonna go, because millions of people did it before you, so it's gonna go. It's not gonna stop at you.
Yeah.
What about the good memories? The good
memories. First of all, I have a really nice colleague, my friend. We studied PhD at the same time on the same topic, electrodialysis.
What is his name?
His name is Shane Walker. He is now a professor at the University of Texas, El Paso. Okay. Yeah, so we did PhD all together and then finished it at the same time.
Oh, okay.
And then, his work more on experiment on electrodialysis, and my research topic was on modeling, numerical modeling on electrodialysis, ionic transport, things like that. Yeah, he is my best friend at the time, and then I think he is my best memory of my PhD studies. And another thing that I very special is when you look at the campus of University of Texas at Austin, it is like a square.
Yeah.
And then our civil engineering building is located on the northern boundary, and then it is 10-story building, and our office was located on the 8th floor, so it is pretty high. And then our window was facing the northern side, so it is the boundary of the campus. And then the University of Texas is located like a northern side of the downtown Austin. Yeah. So on the northern side, there's not high-rise buildings.
Oh,
so the view was
amazing.
View was so amazing. So it is a lot of trees out there, and then small houses there. So and then we have three students are sharing the office, and then my desk was on the window.
So they were jealous for
probably. Yeah. So I think every time I go to my office, I always enjoy the view. So that is one of the special memories that I have for my PhD studies. Yeah.
Okay, I think it's always great to have a friend during your graduate study, especially if you are working in the same lab and on the same topic, and it looks like you are complementing each other's work. Somebody's focusing on the experiments while the other one has a strength on the modeling. So this is a great match.
Yeah, exactly.
But in general, what makes a collaboration between graduate students successful? If 2 or 3 graduate students in your team, they're gonna work together, what makes that kind of collaboration successful and not hurting each other?
That is a tough question for supervisors. I mean, I have multiple grad students. I try to make sure that the role of supervisor in such case is that kind of defining the role of individual students. So this is your area, and this is your area. And then define the area. Okay, you are not going beyond this line. And then you are not going beyond this line. So because this is your colleagues, it's not yours. And then define the area where they can collaborate. So this is the area where you guys work together. So I think that is important. Otherwise, sometimes, one of the students, if they are very ambitious in research, then the students start doing something that belongs to the other students. So I think avoiding that I think that is the worst case scenario when there's a collaboration. So I always try to be careful not to have such situations.
I see that in your career that you had many research topics. I cannot say, okay, if we say Dr. Kim is expert on anaerobic digestion, biochemical electrolysis, microbial fuel cell, microbial electrochemical cells, and then water disinfection. So what are the main research topics that you working on?
My research topic can be anything that is related to water and wastewater treatment. I think that is, maybe that is not a good decision to kind of going back and forth, doing this and doing that, different topics. But I think that is coming from my experience. My PhD was electrodialysis, and then it was 80%. I would say 80% of research was modeling. And then my postdoc, it was microbial fuel cell or microbial electrolysis cell. Of course, it uses electrochemistry, but not as much as electrochemistry in electrodialysis. Yeah. So, and then another thing is the electrodialysis is a physical and chemical system, and then microbial fuel cell is more like a biological system. And then previously it was modeling, and then the postdoc was experimental. So it was a big change, and then I enjoyed the new stuff, kind of new experimental, biological, and different application of electrochemistry. And then what I learned then is that if I have strong fundamental, like environmental engineering, and then kind of wastewater treatment and drinking water treatment, like it is very, very defined, this well-defined system. We are dealing with reactors, and then outside the reactor, we don't really care, but it is not natural water system. So it is relatively simple compared to the very complicated natural water systems. So if you have strong fundamentals, like mass balance and the kinetics, equilibrium, I think those three are all we need. If you have a strong foundation on those, then there's a reactor, and then if there are different reactions, then you apply different principles, different fundamentals, then you can work on it. So I think I at the time I learned that, okay, if the dealing with different system, it is not a big deal. Maybe actually it is something enjoyable. And then after I came here, the big project that I was awarded is anaerobic digestion. Again, it is also very different, and then I enjoyed it. And then at the time I brought both experimental and numerical aspects of anaerobic digestion applications. And then I thought that, okay, I did 3 different processes. Yeah. Why not 4? Why not 5? And then I started thinking about disinfection. and then apply the same principles on different processes. I think that's how I became kind of working on different processes, and then but probably my students may not be happy with it, but that's how I became.
But I would
diver.
say this is a special capabilities for Dr. Kim to jump from a topic to another, because you have a strong scientific background, and maybe because of your experience during your master and your PhD. But if a new professor, a new assistant professor, a new faculty member get hired and seeking your advice, what should I do? Shall I focus on one or two areas, or should I be open to work on multiple areas? What would you advise them based on your experience?
That is a tough question. I think for really junior faculty members, I would recommend to continue on what he or she has been doing for PhD or postdoc.
Yeah.
And then after a couple of years doing the same topic, and then expand to new areas. I think that'd be more careful advice.
So if I ask the question in a different way, if Dr. Kim went back at his first or early career as a professor, would you again jump from different topics, or you would focus?
I'll probably do the same thing.
This is
There are some challenges definitely. If I switch it to a new area, there is definitely a lot of challenges, especially if you submit manuscript, then you get a lot of rejections.
Yes,
but I think I enjoyed working with it.
So, should you have any preference on selecting the research topic?
For me, it is always, I don't think I have a lot of choice. It is mostly on industry partners, sometimes industry partners and sometimes funders. And then sometimes the hot topics in the field. There are certain hot topics. When I did my postdoc, luckily it was MFC was a hot topic, and then afterwards kind of resources recovery and then the nutrient recovery was kind of hot topics. So I try to stay within the mainstream of the field. So if it is hot topic, then if I have enough facilities in the lab, then I will do it. So that is how I choose.
So I would say one of the main reasons is that what we call it the demand, either from the industry or the funder.
Exactly.
Yeah, exactly. And you have the main tools as a researcher, so you can deal with any topic.
Yeah.
Let me do something hypothetically.
Yeah.
If I give you unlimited fund, so Dr. Kim, now we're giving you unlimited fund. Don't worry about the fund. You have that fund.
Yeah. I like you.
Of course you're going to like me. So what would be your future research topics?
My future research topic, if it is not affected by anyone else, then I have two topics. One is SBL, sequencing batch reactors.
Okay.
So in my wastewater treatment courses, in the course, we spend a lot of time on nutrient removal. Kind of very first 1 quarter is organic removal. After organic removal, we talk about nutrient removal. And same thing on research. Kind of government spend a lot of money for researchers so that they can conduct the research on nutrient removal, so that we can develop new technologies for nutrient removal in wastewater treatment. But in the course, I always tell my student, we already have the technology for nutrient removal, very efficient technology. And then the technology, I believe, is sequencing batch reactors. So you can implement biological nutrient removal, biological phosphorus removal, biological nitrogen removal within the framework of the sequencing batch reactor operation. So if I have unlimited funding, I really want to work very seriously on sequencing batch reactors, it was considered as same technology as conventional activated sludge maybe 20 or 30 years ago. And that's the reason why it is forgotten by kind of wastewater engineers. But it was forgotten 20 or 30 years ago because we didn't have to remove nutrients 20 or 30 years ago. But now the story is different. We must remove nutrients. And sequencing batch reactors, it is not the same as activated sludge. It is very different. You can implement various oxidation conditions within the reactor. So I really want to work seriously on sequencing batch reactors if there's sufficient funding.
So let's move to a little bit practical side from the sequence batch reactor, given the fact that most of the wastewater treatment plants are operated with activated sludge or conventional activated sludge. How is it easy to convert the waste activated sludge into a sequence batch reactor?
That is another challenge. But I don't think it is going to be very difficult. Basically, if you can have a good decanter in the bioreactor, and then if you use sequencing batch reactor, you don't need secondary clarifiers. So maybe secondary clarifier can also be used as bioreactors as well. And then one thing, it has to be big if it is designed as a large bioreactor or secondary clarifier. It has to be divided into smaller pieces using baffles so that it can have multiple sequencing batch reactors, so that the plant can continuously receive the wastewater.
But now this is one line of research. I give you unlimited funds, and you mentioned maybe two topics. So other than the sequence batch reactor,
the one is like it is. Have you heard of white hydrogen?
We all know about the green hydrogen, but white hydrogen. This is yes.
Yeah,
but maybe let's explain to the audience. I know that the green hydrogen and the white hydrogen, but if you just explain to the audience what is the difference between the green hydrogen and the white hydrogen.
White hydrogen is more like it is still theory. So the water seeping into the ground, and then the water goes really deep there. Then it is disintegrated, and it is becoming hydrogen gas, and then naturally. The hydrogen gas is produced because of this nuclear reaction very deep in underground. So as a result, hydrogen gas is coming from the ground. And then there are a couple of locations, one in France, one in Africa, where they found the hydrogen gas is coming. So just like petroleum is coming from the ground. So that is the definition of a white hydrogen. And then I still don't have a very solid plan for
I really explore.
This is when I heard about the story, and then one of the theories is that when hydrogen going up and then it meets carbon material, then it converts the carbon material into coal or petroleum. So that is the theory behind it. So, and then the amount of hydrogen production, of course, it is theoretical calculation. It is tremendous amount of hydrogen gas. And then of course, it may not be within the boundary of environmental engineering or water. Of course, it is not definitely water and wastewater treatment area. But that is something that I'm very interested in these days. So.
Maybe let's wake you up from the dream. That is, you have unlimited fund and you have the opportunity to choose the topics. What is the current practical or actual future direction of your research?
My actual direction of research is more on resources recovery and AI application in water quality engineering. So kind of resources recovery, we've been working on biodegradable plastic, PHA, polyhydroxyalkyl or PHB, polyhydroxy butyrate production using microorganisms. So we've been working on Kupfia virus indicator. So this is a very unique bacteria species. They can use carbon source, CO2 as carbon source. So the autotrophs At the same time, they can also use organics as the carbon source. So they can convert waste organics into biodegradable plastic, and at the same time, they can convert CO2, like a CO2 in flue gas, into biodegradable plastic. Of course, there are some certain conditions have to be met to derive such reactions. So we've been working on gravitous indicator for biodegradable polymer production from kind of waste organics and CO2. And another research that we recently started is Ugulena gracilis. Ugulena is also it's a microalgae, and then of course since they are microalgae, they are phototrophs. They receive light sunlight and then they grow, and then they can also use organics. So they are phototrophs at the same time they are heterotrophs. They can use waste organics to grow, and they can also accumulate polymers in their cells. And then the polymer that they make, it is called the paramylon, and then it is kind of immune boosting supplement chemical. So it is very beneficial. It has very beneficial applications. So we recently started working on Ugulena gracilis research project. So those are more on the resources recovery from waste and CO2. So that is one stream of my research work. And another one is like this is nutrient removal. And then I've been working on a variety of technologies, electrodialysis, ion exchange membranes, and anaerobics, and other technologies for nutrient removal. And then another future direction of my research is AI applications. So previously, I was not a big fan of artificial intelligence, and then, but kind of maybe 5 years ago, I thought that no, it is a black box, and then I'm a researcher, and then. So if it is a black box, if I'm in industry, I'm happy to use it. But if it is a black box, then I don't know what is happening inside, then it is not the right tool, right item for researchers. But now the world is changing, and then AI is becoming more and more important. Everyone is now using ChatGPT. So I thought that, okay, maybe even though it is a black box, even though I don't understand it, maybe I can use it in my research. So one of the applications that I am currently working on is using deep learning AI algorithms for identification of microbial species in microbial images. So one of the recent project is to take a lot of microscopic images in secondary clarifiers or in bioreactors, and then we figure out how much of the cells are flux-forming bacteria and filamentous bacteria, so that we can correlate the results with sludge bulk index or sludge bulk problems, sludge volume index and sludge bulk problems. So that is the relatively new research project that we are working on now.
I have one comment and one question.
Yeah.
So, for the application of AI, did you hear about the plastic net that Wayne Parker and his team in Waterloo developed recently?
No, not really.
I think it is the same methodology that you are thinking of, using the microscope images and treated by the AI machine to identify, for his case, to identify the plastic or the microplastic in this case. And they are in the development stage, but it's quite something interesting. One of the main advantages of AI application on our sector, it can be really helpful. So I think this is the same concept of the AI.
Yeah, the concept it is not totally new. Actually, there is a commercial product that is using AI for identifying harmful algae cells. So there's an algal bloom, they take sample and then they put the sample into the machine, then machine take a lot of microscopic images, and then kind of algae cells, they have natural pigments, right? So green color pigments, so it recognizes which species, whether this is a harmful algal something like that. So it is not totally new.
Okay.
Right? Yeah.
It's great to hear that we have those kind of development in Canada. Going back to the first topic that you mentioned that you are interested in, which is the bioplastic production, which is a big topic nowadays, which is high demand from all over the world to reduce the plastic production, especially the microplastic. What are the main challenges for the bioplastic production?
That is a good question. Actually, that is not, maybe I made it too broad. My research work is more on the Kupffer-Peters indicator characterization, its growth and accumulation characteristic. But I do know the biggest challenge is the purification of the bioplastic in the cell. So breaking the cell, taking out the plastic, and then separate it from other cell materials. I know that is the most one of the biggest challenges in the field, but that is not our research. So because I realized, okay, it is too difficult problem for me to solve.
Yeah. Okay, let's take a little break from the research and the sci-tech and have a moment about having a strong team or an excellent team is crucial for our work as a professor and for sure for achieving something great. And I would say it's one of the toughest things is to select a good student. So for Dr. Kim, what are the criteria that you are looking for selecting your graduate student?
Yeah, I'm trying to look at two aspects when I interview applicants. First aspect is kind of attitude, kind of whether the
attitude.
Yeah, whether the applicant has positive attitude.
Okay.
I think positive attitude is really, really important, not only for the research, but also for other kind of daily life things. I think positive attitude is very important. And another important aspect that I am looking at is diligence. So, I think being smart, I don't think that is, being smart is not a very important characteristic for good researchers. I think diligence, especially in engineering fields, maybe it is different from in other fields, but in the engineering field, our research is basically trial and error. So if you give 10 trials, and then if you give 10,000 trials, then the results are going to be totally different. So I think really important characteristic of engineering researcher is diligence. So yeah, I try to look at kind of diligence in applicants.
Okay, so typically you do an interview for the potential students, and then you try to see those two main criteria on the potential students. But nowadays with the increasing the communication tools, we receive many emails from all over the world from potential students that asking for an opportunity or even contacting us through LinkedIn or other communication. So if you receive those emails, would you discard them or look at them, or there is a key message for the students who are sending you an email that is you can look at it?
I always look at undergrad transcript.
Okay.
Yeah. I may not look at CV, but I always look at undergrad transcript, because when you look at undergrad transcript, you can see whether the student is diligent or not.
Okay.
Yeah. So if it is a diligent student, then you can see it. There's an improvement starting from good grade from the first year of the undergrad and then until the end of it. So if it is consistent, then at least I can say, okay, that this person or this applicant had a very diligent life during undergrad studies.
So this is a straightforward hint to the students who's going to contact you. If you are contacting Dr. Kim with email, please attach your undergrad transcript so you can make his life a little bit easier to look at it and decide if you have potential or not. Okay.
Yeah,
that's a great one.
Yeah, that's the kind of message.
Yeah. So as a professor, you are a trainer for the research team that working with you. And sometimes the students or the graduates cannot make a decision and don't know their path. And they keep asking this question, which path should I take? Should I go to academia as a professor or seek an industrial career after getting my PhD? What would you tell them?
Oh, that is really difficult question as well. One thing that I found in my personal life is that I don't know. I don't know very well about myself. I don't know what I really want to do until I actually do it.
Okay.
So my advice would be, okay, just go ahead and do it. I mean, if you just apply, whatever offer that you have, then if you have multiple offers, then it is good. But these days, kind of very competitive to get offers, both in academia and industry. So if you get an offer, just go ahead and then do it. And then if you do it for a year, then you will know whether you like it or not. Until you actually do it, you don't know. It is very difficult to know whether you actually like it or not. So
it's a little bit hard because for industry, yes, you can go try for 1 year, 2 years. If you don't like it, you can change even the industry itself or the area. But for academia, if you join the academia, you cannot say, okay, I'm gonna go and try it for 1 year and think that's it. But okay, let's rephrase the question in a different way. And new students come to you.
Yeah.
And you have 2 new students starting their PhD with you. And one of them, straightforward, he knows his past and said, Dr. Kim, I want to go to academia. I want to be a professor. What would you advise her or him?
My advice would be publish. Number 1, publish, and number 2, publish it. Number 3, publish. Yeah, keep publishing.
So the number 1 criteria that any graduate student looking to be a professor is the publication.
Yeah, publication.
In terms of quality and quantity.
Yeah, both quality and quantity.
But I would add to that also to be like in doing a volunteer work and getting your networking as well. So this is something really, we are looking at it for the academia as well. So publishing can be number 1, but also working on the teaching and the service, because those are the 3 criteria that we typically look. But publishing is number 1 category. So the more the publication makes your career easier. What about the one that is, I don't like the academia. I don't like that teaching that much. I want to go to the industry. I want to make money. And she or he wants to pursue an industrial career after the PhD. What would you advise them
for
the PhD, during the PhD? What they should do to be ready for the industrial career after getting the PhD?
Okay, I'm not sure whether, I don't think there are a lot of students who, there are not a lot of PhD students who wants to pursue industry career. But I mean, if there are, I want to emphasize more experience, lab experience, as well as more of the socializing. Like I want to emphasize attending conferences, not only in academia but also in industry. And so try to make a lot of connections in the industry. So making connection would be an important objective of her or his PhD studies, as well as, of course, work on kind of lab work as well, kind of having more and more different experiences from industry, which can be applied later on.
Okay. So with the current, economic situation and challenges on finding a job, some students finished their PhD and they couldn't secure a job. And, job hunting is a really big thing for them. So, and the student came to you and said, Dr. Kim, I have finished my PhD 6 months ago. I keep trying to apply for a job and they didn't get a job yet. What would you advise them?
Oh, that is really tough. My suggestion is just apply more. That'd be my my suggestion.
So never give up and apply as many
never
as you
give
can.
up, and then try to maintain positive attitude.
Yes.
Yeah. One of the things that I found is that kind of a lot of people, of course, all people, they like positive people. They want to hire kind of industry. They want to hire positive people.
Okay.
So
Yes.
attitude is very important. So when you have an interview, I try to maintain positive attitude.
Okay.
Yes, that'll be. And then if the student is pursuing the academia, then again, publication is going to be emphasized again.
Yeah.
Yeah.
Okay. So, generic question for a new student. So, a new student joined your team. So, what is a general advice would you give to them when they join your team?
My very first advice or direction is go to the lab, start the experiment.
Yes.
That is
This is a big shock.
Yeah. I think that is hands-on experience is very important. I mean, especially for graduate students. Yeah, I mean, some students spend 6 months or even a year to do literature review. That is literature is absolutely important. But when they started, then my suggestion, okay, within a month, go to the lab, complete all the safety training, and then do the first experiment. Because I know the experiment is not going to be successful. It is going to be failure. And then our research, especially in experiments, it is like this. We do first experiment, it's a failure, obviously, second failure, third failure, fourth failure, and it keep going. But each failure, we learn lessons. So the fifth one is going to be better than fourth, and sixth experiment will be better than fifth. So there's an improvement in the quality of the data from the experiment. And then if you reach a certain level, then the data are now reliable enough for publication. Then now we make the results into an article. So I know the procedure. So, and then I think for a new student, very first thing that the student has to do is to experience the first failure.
Okay.
And then how to deal with a failure. I think that is a very important thing. So if there is a new student, and then I'll send the student to the lab. Go ahead and then start your first experiment.
It's quite interesting to give a big shock to the students at the beginning. Go to the lab, face the failure, get used to it.
Yeah.
But it's not always the case in our research that to face that many failure and to be resilient or resistant to those things. Sometimes you go to the lab and experiment works.
Yeah.
So you would be happy. So you did a meditation, so maybe we can just relax and forget being a professor. And we said, Dr. Kim, if you are not a professor, which career would you like to pursue?
I thought about it some time ago. I became a mathematician if I didn't work on. That doesn't mean kind of professor, but I mean, yeah. So during my master's degree, I took a lot of not taking. I audited not a lot, several. Courses in the math department because my research was on numerical modeling. So I took numerical modeling course in math department.
Okay.
And then I realized it's very different from the numerical method course in engineering.
Yes.
So I thought, okay, it is interesting. It is very interesting aspect of numerical method. So I thought that kind of how about taking auditing other math courses, and then one of them was linear algebra. And then in engineering, when you take linear algebra, it's like all matrix operation, right? Matrix operation, and then determinant, and then eigenvalue, eigenfunction, things like that. Linear algebra in math department, it is not like that. It is. They start from maybe 8 or 9 axioms, like it is closed for addition, closed for subtraction, things like that. Starting from those very basic axioms, and then they create a world of numbers. Yeah. So like using those axioms, they make a theorem, and then based on this theorem, and then they make another theorem. So basically, characterize the world that has this 8 or 9 key characteristics, and then I was so fascinated, and then at the time, maybe I should have gone to
maybe it's time to change your career.
Maybe it is too late. Maybe not.
Dr. Kim, it was a really pleasure meeting you today, and I really enjoyed talking to you. So thank you so much for accepting the invitation again, and thank you for being our guest. Thank you so much.
Yeah, thanks a lot. My pleasure.
Thank you. Thanks. Okay, everyone. So this is the end of this episode. I hope that you enjoy it, and seeing you in another episode.